next guest is Chris Alexander. Chris is Chief Strategist for the Internet of Things, Connected Devices, and Cloud Gaming at Akamai. Chris drives thought leadership in the industry as well as decisions on Akamai's future technologies, working with key device platform businesses to embed Akamai's software and compatible implementations. Welcome, Chris.
Thank you, and welcome everybody. I'm going to talk a little bit about realizing the promise of IoT. Oftentimes, in the Internet of Things, we talk about all of the opportunity and all the wonderful things it can do, but in terms of realizing the promise, there are some challenges that we still need to overcome, not only as individual companies, but as an industry and ecosystem. I find one of the easiest things to start off with is a generic consumer B2C example, because we all have homes, we all have devices in the home. It's something we can all understand in terms of the problem set. So I'm going to walk through some examples of some of the challenges just in this type of ecosystem that we'll see. First, let's look at the complexity. So as we all know, in our homes, we can have things like phones and connected health bands and video monitoring, smart door locks, smart thermostats, smart light bulbs, smart audio video systems. They're all connected in. And some of these have to talk directly to each other, some have to talk through each other as tethered systems, and they're probably talking through a gateway Wi-Fi router, maybe a small cell in the home. But this is kind of how things work in your home. And then they have to go back up either through a mobile or fixed line network across the internet out to some data center to provide you the services that that you'll be using as a user. Okay, so how do you reliably connect all these different machines and protocols at scale? Because they don't all speak the same language. Some of them speak Zigbee, Z-Wave, Bluetooth, RF, IR. Some of them don't even have a full TCP/IP stack, which isn't a bad thing because you don't want your light bulb to have a heartbleed problem. The next challenge. Let's take, for example, the data that these things generate. That needs to go all the way back up through your gateway Wi-Fi router, all the way up the fixed line or mobile network across the internet to some data center so that you can monitor how this equipment's performing. Are there any other services that you need? Can you do proactive support with the equipment? And it helps these businesses as they're looking at how they're going to figure out new services to build on based on the usability of the current devices. Well, I just showed an example of one packet. However, as you look at this at scale, and all of these things generating data, maybe within seconds or milliseconds each, across lots of different homes, you begin to have an inbound scale issue. And if you look at the infrastructure today, a lot of the infrastructure has been built for outbound scale. We've scaled so that we can, do lots of things around World Cup and Olympics and big software updates, scaling data out to the endpoints. But as we look into the world of IoT and the data that these devices generate, there's going to become an inbound scale issue. The next thing is a lot of these devices talk to each other. They may talk directly to each other, going back and forth with messages that they need to pass to each other securely and reliably. And some of them may need to go up through a data center to hit a server before it comes back. I just showed a couple examples of how the packets might pass back and forth in the animation between these devices. And much like the data collection example, I could have added in lots of other packets, and you can picture in your mind all of these things constantly talking to each other. How do you ensure that this all happens reliably in a fast and efficient way so that, when you want to make sure your thermostat's on in your home, it goes on at the right times. You want to unlock your door, it's working at the right time. You need to make sure all of these things just work, because it should be as simple as hitting a light switch. The other thing is that all of these create vulnerabilities. So if you think of this from a security perspective, how do you ensure control and protect this massive attack surface? Because imagine a DDoS attack being initiated by a bunch of thermostats and light bulbs. That's pretty scary. We've already seen some of the inklings of what things like this could be with the Bash and Striker attacks that have happened. And it's probably only a matter of time before we see something much more nefarious that's leveraging all of these Internet of Things devices to do coordinated attacks. It could be against large organizations, or it could be against your home. Now let's take a step back. I gave the B2C example because we all understand what it's like in a home. And I washed away the home and the home device examples. And what really, if you want to genericize it down, you have compute layer devices, things that can create, process, modify data and instructions. And then you have sensors and switches, things that can either receive or send data and instructions. And they may be direct, tethered, untethered, integrated with a compute layer. And as you start to look at the Internet of Things, we often talk about traffic logistics, power generation and distribution, manufacturing, healthcare. So it's far beyond the example I gave. What I wanted to do is take the step back and say, you can look at this more generically in the model because you're still going to have those sensor switch layers, you're going to have compute layers, and then it's going to go further up through the tiers of infrastructure. And this is how to look at one way of looking at the complexity of the problem. And also the challenge now is when you look at it like this, how do you ensure it's all fast, reliable, and secure? Because it just needs to work. Now, especially as you start to think of some of these industrial and enterprise examples, the power better work. Medical systems that are monitoring patients better work. And so this is where intelligent software is going to become critical. Because how all of these things work together, communicate to each other, so they can be fast, reliable, and secure, is going to be very important as an ecosystem of how we approach solving the problem. So at the first layer, you're going to need connection layer software. You need these devices to be able to connect to each other and talk a similar language. So I talked about earlier all the challenges of them speaking different languages. You need some type of translational layer so they can speak a similar language, so they can work together. The next step is you need to layer in either specs or beaconing, something that is common in terms of how you can package up data so that it can be sent up through a network that can be collected and used. So you can make business decisions and you can also monitor and control the different devices in an ecosystem. In addition, you need these different levels to be able to work with each other from a real-time messaging perspective so that they can broker messages at the appropriate places further out the tiers of the network, so that all those messages don't have to come up through the core because it's far more efficient. And you need to be able to ensure the reliability of these messages that are passed between devices so that they can operate as efficiently as possible. The fourth piece is you're going to need security, and security at all layers, because all of these new devices, sensor switches, open up new vulnerabilities in terms of opportunities for attack. And the last piece is having data analytics, APIs, plugins, so that you can actually get the data out to now make decisions around how to run your business and how to improve operations of the business. And so these are just some of the things that we believe are important as considerations for looking at the Internet of Things and realizing the promise. Akamai is committed to working with players in the industry, and we're very interested to engage with anyone who has initiatives in this space. Thank you.